So I would say this is belong to that the kNN algorithm, that something about how to use the package efficiently. So the first thing is when you train the model. Now remember now after like a half part of the semester, we are doing something called the supervised learning. And this means that we have the answer. For unsupervised, like a k-means algorithm, you just input the x. For unsupervised, you use the x to make x new, something like that, or x to y. So anyhow, you don't have any label, any answer beforehand. But now you have x and y. It is basically saying, okay, you give me x, but also you also tell me what is the number written on the image, and that's written as y. So you have the answer. So in this case, you are able to determine what is the score of this accuracy. How is your performance of this algorithm? So one of the things you can do is called the accuracy, to calculate the accuracy, 精确度 of that. Accurate is the adjective, and accuracy is the noun, the number. And basically this is one kind of the score. Just like your score of the semester, it is showing what is the performance of yourself or this algorithm. Okay, so there are at least two ways to deal with that, but it is very straightforward. Accuracy, the formula accuracy is the number of correct answers divided by total number of questions. Say for example of your final exam, if you got 10 questions and then you got like 5 problems correct, then you got like a 50% accuracy. That's the idea. So this is a very simple arithmetic, and for sklearn there are some functions helping you to do this, or you can just write a code for yourself. So I will just let you know there are two ways to deal with that. One is from sklearn, the metric. Okay, notice that this is ME matrix. Matrix is like a distance, or giving you a measure of something, 测量的意思. Okay, so sometimes you will see, okay, what is the metric of this data? How does it look like? Can you tell me something about it? Okay, tell me something about something, some measurement of something. Okay, and in this module or folder, there is something called accuracy score. So you can do it by this way. For kNN model, you can also use the model. This sounds a little bit easier, right? Model.score. Then you can also achieve this accuracy. So the thing is, basically inside this metric, you have all sort of different kind of scores. One thing is the accuracy for this kind of classification problem. There is also something called the mean square error for linear regression, and in that case, you know, the mean square error should be lower to be better. Lower means better, but accuracy should be higher to be better. And there are something else like R square for statistic. R square, oh, not that R, okay. This R. You know, I teach linear algebra all the time, so we write this R all the time. So bear with me, there is something R squared score, and in that case it is higher, it is better. So you have to understand the meaning of each score, but in general it's an indication of how good is your training. Okay, so basically these two are exactly the same. The reason is for the kNN model, it will set the score as this one, because kNN is suitable for accuracy score, and for linear regression the default score is R squared and something else have a different score. So for this part you can use either way to get the score. That's the first thing. The second thing is that there is a folder called model selection. Okay, so inside here it provides some tools to help you to select the model, and you have several different models. Say just k-means and db-scan. You can decide which one you want to use. But even just for k-means, you can decide whether you want to use k equal to 3, k equal to 4. So model selection is a lot of tools helping you to determine which model you should choose and how to set the hyperparameters. Hyperparameters are the parameters that you set beforehand. It is not the parameter that you are training. It is the parameters that you set. Just something like a k and the mean samples and like a EPS in the db-scan, something like that, when you have to set beforehand. So usually it is like this is hyperparameter. You set this up and then start train the model. Right, for example, k-means. You set the k equal to 5 and then you do model.fit. And then this process will train the parameters inside. So notice that this hyperparameter is different from this parameter. This parameter, when we say that, usually it means that something like model dot components, right? The centers. Something with the underscore in the end. Okay, you got the intercept, the coefficients in the linear regression, and those things will change during the training. But hyperparameter is something that you do that before training the model. And after that, all the parameters will be changed. All right, so model selection is the process to help you to select the appropriate appropriate hyperparameters or appropriate model. And so at least there is one thing that you can do, and it is very straightforward. It's called train. What's that? Train test split. Okay, so the idea is sometimes you only have one set of data. Okay, for example, when we have the digits, the set of digits, maybe we have 1700s of data. And if we train the model and then we calculate the accuracy, then yes, it gives you an accuracy. But the idea is that if you use this one to train the model, and then you again use this one to test your accuracy, then it's like it's like an open book exam, right? So in the end, you know the answer, and then you hope that the model know the answer. So it's not really reasonable. I'm not saying open book is not reasonable. Open book is good. Now ideally you can split that into the training set. I believe you have been hearing about this, and the testing set. And the idea is you got part of X. Part of X, you can call that X train. And you can get the other part of X, and it's called X test. Okay, so you can split this, and you can also split Y into two parts, and one is the upper part, the other is the lower part, and the Y train and the Y test. So what you are going to do is use the X trend and the Y trend to train your model, and everything is set, and after that you can use X test and the Y test to get the idea, to check what is the performance of your model. Okay, so the reason I'm saying this is the following. I forgot. Oh, okay. Okay. The reason I'm saying about this is particularly for kNN. If you imagine the situation, and I believe you understand what I mean by kNN. Okay, when you set kNN with k equal to 1. Okay, that means that every time I just ask my closest friends, should I vote for 0? Should I vote for 1? And then whatever my friend says, then I will do the same. But this language is a little bit different in the context of our machine, because if you have a point, then what is the closest point of it? Well, the closest point of this point is itself. So if you ask the opinion of this point, then you will ask itself and to determine, okay, what is my label? So all the time, if you train the model with k equal to 1, and even worse, if you do the training set equal to the testing set. Okay, this is if. If you do it with these two settings, then for sure you will get always 100% accuracy, because you know the answer and then you ask the answer to answer your question, and this is called cheating, right? So particularly for kNN, you can always achieve 100% if you have the training set and the testing set the same. So that does not make sense. It's the importance to emphasize that in general you have to split the data into two parts. And later on I will demonstrate some code on this. Okay, and the third point I want to say is basically some pros and cons for kNN. Pros means the good point. For kNN, the idea is it is very straightforward. You know what it is doing, right? It is very easy to understand, and even with somebody never had the experience of programming or like mathematics, or you just say that maybe 20 or 30 minutes, you should be able to explain kNN to the a person, right? It's very straightforward. Okay, but ARD? I don't know. Okay, but the controversial thing or pros and cons, the bad thing about kNN is it could be slow, and the worst thing is you can imagine that nowadays it is easier and easier to obtain the data. Okay, so in general we think the more data is better because you can train the things much a bit more accurate. Okay, for example, if you train the digits and then you realize that, okay, the accuracy is not so high, it's 80%. So what you are going to do, maybe you will collect a bit more data and try to do the training again. But quite unfortunately, for kNN, the more data you have, the prediction step is slow. And actually it is slower and slower when you have much more data. So the drawback of kNN, it gets slower and slower when the number of sample is bigger and bigger. when data is big. Well, and that somehow contradicts to our idea of the big data, right? So you see, the idea of the artificial neural network, although I did not teach you about this, the nice thing about neural network is you can use the big data. You can use the big data and then train that, and then some rich company like OpenAI or like Facebook, they train a huge big model. They use a lot of GPU, CPU, and electricity and a lot of knowledge on that. After that, the model itself is simple. If you want to do the prediction, it only takes a few seconds. But in contrast, kNN does not do a lot of training. It only stores the data, and then when you really want to know what is the prediction, you still have to go through all the distances and then find the smallest one and then make the vote. So this one is it is a good model. I just want to let you know there are some drawbacks for this one, particularly when you have more and more data, and the performance will be much and much slower. It could be longer than your training time of your neural network. Okay, let me see if I could pull up another image to say one last thing. I forgot to do this beforehand, so let me find it. Okay, so let me use this image to say one thing more. Oh, wow. Okay. That's weird. Okay, let me do that again. All right, so I will use this image to demonstrate a few more things. Okay, so we have been talking about the image for a while in this week, and pretty much an image is a lot of numbers. For example, let's say, let's switch that 0 for the white, 1 for the black. Okay, so 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 0, 0, 1, 0, 0, 1. Okay, and in terms of our visual feeling, we will feel like these two pictures are the same, right? I would say this is an image for number 1. This is also an image of number 1. After all, I am not going to be accurate all the time to write it on the middle, exactly the middle, right? So sometimes when I write a 1 in the middle, or I write it a 1 on the side, it just means 1, right? But in contrast, you can also write the 0 like this, and it is 1, 1, 1, 1, 0, 1, 1, 1, 1. But this is just like an artificial but small example saying that the distances does not really make sense. Okay, so let me just write one of this. This one will be attracted to the vector 1, 1, 1, 1, 0, 1, 1, 1, 1. And this guy will be attracted to 0, 0, 1, repeated 3 times. Now if you calculate the distances between these two, it's basically calculating how much the digits are different. You got 1, 2 different, and then different, and also different. Okay, so let's see. 1, 2, 3, 4, 5. You got 5 digits difference. So the distance is the square root of 5. If you take the difference and then take the norm of that, it is square root of 5. You can do the same thing for this image and this image, this image and this image. Then you will get square root of 7 and square root of 6. The number does not really matter, but I want to kind of point out that based on our feeling, these two images should be closer than 0, right? 0 is something else that we don't want. This one should be far further than these two points. It should be a cluster, and here should be a cluster. But if you just look at the geometry, it's almost like a triangle, right? The distance from here to here and here to here is almost the same. And even worse, if you pick this image, you want to X kNN to make a prediction. You X the kNN, now you only have 2 data. So you will X the closest one. You X the closest one is the square root of 5 and square root of 6. Then you will X this one. So this image is actually closer to 0 than 1. So this example just want to let you know sometimes the distance might not make sense. This is because when we flatten an image into a vector, it loses all the positional information. You just put it as a vector, and you don't really care about the position, and it's somehow weird. And that's why in the end there is a neural network called convolution neural network. You will try to capture some other information rather than just take it as a vector. Okay.